as they say. So what your task is here, look how tiny my arms look on this thing. What your task is here is just to write down what I write, okay? Ask questions if you have them, and stay focused. See if you can go under the camera or down. You did it. All right. Okay, so just remember I'm recording, so don't try to stay out of the line of sight of, get how short my arm looks, like a little dinosaur arm. Okay, I don't know. Mr. Morelli, can you grow up, sir? No. Well, this one's not any good. You got 1,000 markers up here, but they're all dry. Okay, we're going to use the McRibutive property. So we have -4, open parentheses, a minus 3b, okay, plus 2, open parentheses, 3b minus 5a. So I want to repeat, your task is to simply copy down what I write, okay? So step 1 is to draw your distribution lines like this. This tells you what you're going to do. You're going to distribute, multiply these numbers through these binomials, okay? So our first step is -4 times a. -4 times a is -4a. And now we do -4 times -3b. -4 times -3 is positive 12. So -4 times -3b is positive 12b. All right, I'll try to move my head. Now, because this is a plus sign, we know it's going to be a plus sign since this is not a negative. 2 times 3 is 6, so 2 times 3b is 6b. Now 2 times -5 is going to be -10, so 2 times -5a is -10a. That was the distributed part. Now we combine like terms. So I like to draw these lines. So I know I'm going to combine the -4a with its like term, the -10a. Now when those two things combine, you've got a -4a and a -10a. You put them together, what have you got? -14a. Bippity boppity boo. And now these two middle terms, I'm going to combine them together. 12b plus 6b, 12 plus 6 is 18, so plus 18b. Okay. Now go ahead and put that in a box. All righty. Give me just one moment here. Start looking at number 2. They die hard. Like the movie. Yippee-ki-yay, Hans. So we're 1 down, 7 to go. It's being recorded.
May I go to the restroom?
Yes, just try to stay out of the line of sight of the camera. All righty, ladies and gentlemen, number 2. This one wants us to take this point-slope form equation and rewrite it in slope-intercept form. Quick reminder, slope-intercept form would help if we stated what that is. That's the y equals mx plus b form, okay? So this point slope form that they give us is really easy to convert. It's y minus 2 equals 3, open parentheses, x minus 9. Quick sidebar. The point slope form is y minus y1 equals m, open parentheses, x minus x1, close parentheses. So this is something that I would ask in a maybe an advanced class, but we'll do it in here since y'all are smart and since I'm here to help. You can actually look at this equation up here and tell me what the original points were. All right, think about it for a minute. It's y minus y1. So y minus 2. Therefore, the original y value must have been 2 that they used. You see, because it would be y minus y1. If y1 is 2, then it's y minus 2. Look over here. X minus x1, x minus 9. So the original x value must have been 9. Isn't that cool? And the slope is 3, m, 3, m, okay? So the m value was 3. Isn't that neat? That's why point slope form is so cool. Now let's go ahead and do this. So it wants us to somehow turn this into that. So what we're going to start by doing is run these distribution lines here. The left side does not change. So we just rewrite y minus 2 equals. We didn't touch that. 3 times x is 3x. 3 times negative 9 is negative 27. You just write minus 27. Now to fully resolve this, we have to do additive inverse. Very good. So we do plus 2 on both sides. And we have y by itself on the left equals 3x negative 27 plus 2. So I'm negative 27, negative 26, negative 25. Okay. There it is. So this is now in y equals mx plus b format. So just so you understand, we were able to extract this information from the original problem, but now we know something else. We know that the y-intercept is at negative 25, okay? Which means the y-intercept is at the point 0, comma, negative 25. And if you pay close attention, you now have 2 points. You have this point that you were able to pull out of the original, and you know this point because you know the y-intercept has got a 0 for its x value. So you could, if somebody wanted you to, you could plot these 2 points and draw a graph, okay? Similarly, you could draw a dot at 0, comma, negative 25, and then use the rise and run of the slope to plot more points, like up 3 over 1, up 3 over 1, up 3 over 1. Okay, I know I went into more depth on that problem, but that's the, might as well, right? Just review everything. Okay, 2 down, and I'm not good at math. How many to go? 6? All right. Number 3, we got to read this one. It says, what is the domain of all continuous linear functions? So the 2 words that are important here are continuous and linear. Obviously, domain is super important. Okay, so let's just kind of outline what we got. Domain is x. Domain is x. This word continuous means that it's a solid line. Okay? In other words, there's no breaks or gaps. It's not discontinuous or finite or discrete. It's a continuous kind of smooth, well, I don't want to draw a curve. That's the last thing I want to draw. It's a smooth line. So that brings us to the word linear. So let's underline the line part of linear. Linear means that it's straight line. Straight line. So let me show some quick examples of what continuous curves look like. So here's a little simple graph. And here's a continuous line. Continuous linear function right here, plotted. Okay, here's another one. Okay, arrowheads on the end. This would not be a continuous linear function. See that little dot there? That means there's a discontinuity. Okay, so these are continuous linear functions. So we're talking about domain. That is, what x values can these lines take on? They can take on any and all x values, infinite in both directions. So the answer to the question, what is the domain of all continuous linear functions, is all, what else am I going to, what do you think the next word is? Starts with an R, then the next word starts with an N. All, say it again. What's the opposite of fake?
Real.
Ah,
Numbers.
all real numbers. Okay. You know, they call it real numbers because when you get into Algebra 2, you're going to learn about imaginary numbers. Okay. Now, you can write the answer like this, but on your state exam, it might be presented to you in inequality notation. So I want you to write both of these answers down. This is the inequality notation for this thing I just wrote in a box. Negative infinity, less than or equal to x, less than or equal to positive infinity. Okay? This is the inequality. These two things are identical. This means all real numbers. This means all real numbers. Are you comfortable with that? Remember, domain is x. Range is y. Okay. So we're going to erase this. Moving on, it is being recorded. If you didn't get it written down, there is a recording. Number 4. What is the domain of x equals negative 5? Domain, that's x, right? And so they give us this equation, x equals negative 5. Bro, is this a function? Is x equals negative 5 a function? No. But it still has a domain. So the picture is very illustrative. Okay, so let's draw the picture. You've got your XY coordinate plane right here. And then you've got this negative 5 over here, okay? X equals negative 5 is a perfectly vertical line running parallel to the y-axis. So because it never crosses the y-axis ever, anywhere, it's not a function. Because the two dimensions, the x dimension and the y dimension, they never interact with one another. And for it to be a function, they have to interact. But that really doesn't have anything to do with the domain. I'm just telling you that. Now the domain is x. So what x values can this vertical line be? So what is the x value at this dot right here? What is the x value at this dot right here? What about down here? What about down here? What about down here? Yeah. So everywhere all along this vertical line, the x value is negative 5. Domain is x. So what is the domain of this line? Yeah, negative 5. And so the way you write that, there's two ways. You can use curly brace, and then you can just write negative 5. Close curly brace. Congratulations, you're done. Or, and this would be preferable, write -5 less than or equal to x less than or equal to -5. And if that seems like, well, why would I write that? It seems a little stupid. Well, you're right, but that's kind of how the STAR test likes to present these things. Okay, coming up, number 5. Number 5. Let's write that down. Can I erase? Okay, number 5. So this time they're asking us for the range. What letter goes with range?
X.
Y. Okay, range is y. And then the equation they give us is y equals -5. Okay? Does anyone know what this line looks like? Remember, x equals -5 is a perfectly vertical line going through -5 on the x-axis. What does this line look like? A perfectly horizontal line crossing through -5 on which axis? The y-axis. Very good job, guys. So let's draw it so we get a picture. We're always going to be drawing these pictures. It's super helpful to do. So down here you've got -5, and then you've basically got this perfectly flat line like this going for infinity and all eternity in both directions. So what is the y value here? How about here? How about here? How about here? Here, 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 here. Everywhere along that line, the y value is always the same, -5. Range is y. So the range is -5. Inequality notation is -5 less than or equal to y for range less than or equal to -5. Put it in a box, like Roddy Rich. Everybody is ready? Okay, y'all are doing great. Number 6. It wants to know the slope of, and then it gives us 3x minus 4y equals 8. Okay, what is the slope of this? Okay, you've got 3 options. I'm going to give you some choices. What type of line equation is this? Is this slope-intercept, point slope, or standard? Let me give you all 3, okay? Slope-intercept is y equals mx plus b. Does this look like that? No. How about point slope? Y minus y1 equals m, open parentheses, x minus x1, close parentheses. Does it look like that? Standard form is ax plus by equals c. Does it look like that? Yeah. So in these 2 equations, the slope is given to you. You see it's m. M is slope. But here you have to calculate it. So slope in standard form, you have to write this down. The equation is -a over b. It's not that hard. -a over b. So what you need to do in these problems is identify what a, b, and c are. Well, this is a, this is b, and this is c. So a is 3, b is -4, and c is 8. So the way you write this sentence is if m equals -a over b, and a is 3 and b is -4, then, if then, m equals -3 over -4. Now, a negative over a negative is a positive. So you can say m equals 3 over 4. You're being signed out. Try to walk underneath that camera lens so I don't. This will be on YouTube later, okay? It'll be on Google Classroom and YouTube. All right, are we ready to move on? All right. Some of you are like, man, I was ready 10 minutes ago. I was born ready to move on. Anything to get it over, sir, please. Okay, have a good day. Okay, number 7. Expand. So you've learned how to add, subtract, multiply, and divide. Now you're going to learn how to expand. Expand what? Expand the binomial. Okay. What binomial? This binomial. Open parentheses, x minus 3, close parentheses, squared. This can be extremely confusing. The question might come up, what do you mean expand?
Hold on, wouldn't it be x negative a?
Let me show you, okay? Until someone shows you this, it can be confusing. You see how this says x minus 3 squared? Like if I write -5 squared, that means -5 times -5, doesn't it? If I say 3 squared, that's 3 times 3, doesn't it? Isn't it? So there's no difference, folks. It's x minus 3 times x minus 3. So step 1 is to write open parentheses x minus 3, close parentheses. Open parentheses x minus 3, close parentheses. Okay? Please be writing this down because this stuff is going to come up over and over and over again. Because I'm recording, I won't use names, but there is a person in this room who has a sibling who I came into my room later on in their high school career. This came up again. It was in Algebra 2 that they had to do this. And, you know, so you want to pay attention because you have to do this again. You have to do it in geometry. You have to do it in Algebra 2. So I want to show you an easy way to do this called the box method, okay? So over here, we're going to say box method. Step 1, draw a box. Now, do you guys know what Punnett squares are from biology? Well, this is basically the same thing if you've ever heard of that. So take a look at what I'm going to draw. I'm going to draw like a window. So I know I'm blocking it, but give me a sec. So you draw a box and you cut it into 4 pieces like this. Box cut into 4 pieces. Now what you do is you write this thing, x minus 3 up here. X, and then the -3 kind of by itself right there. And then here you write x, and then you put a -3 right here. And now your goal is to fill in each box. So the way you do it is you multiply. X times x. What is x times x?
1. 1x.
X squared. Okay? X squared. What is x times -3? -3x. Question, what is x times -3? See, it came up again. X times -3. You already know this one. -3x. And finally, so to fill in this box, we do -3 times -3. 9. Okay, so the answer is actually written here. Okay, we just have to put it together. These two terms that are diagonal, draw like a tic-tac or pill shape around those terms because you're going to add those together. So let's do that now. What is -3x plus -3x?
9.
Add. Add. Don't
9.
multiply.
Wait.
-3 plus -3 is -6. So yeah. So here's what you're going to do. We always write these out using the biggest exponent first, then anything with a letter, and then the thing that's just the number by itself. This is called the constant. So whenever somebody says constant, they mean the number that has no other letter with it. That comes last. So first we're going to write out x squared. Then we're going to write out -3x. Then we're going to write out -3x again because that's here. Then we're going to put plus 9. Okay. Now we already combined. You see how these are like terms? They both have x's. So our final statement will be x squared minus 6x plus 9. So this is what is meant by expanding the binomial. You went from a binomial, which means bi means two terms, to a trinomial, 1, 2, 3 terms. Okay? So binomial to trinomial. That's what's meant by expansion. Now there's another way to do this. There's another way to do this called FOIL. And you must learn both ways because I'm going to tell you, some teachers will demand that you use FOIL. So over here, we're going to write FOIL. F-O-I-L. FOIL. F stands for first. O stands for outer. I stands for inner. And L stands for last. Okay? So let me show you something cool. A student taught me this. What it means is, for first, it means multiply x times x, the first terms of the binomials. So draw a line like this. O means outer, so that's x and -3. Okay, so I draw this. And then it's inner, -3 times x, so I draw this. And then it's last, -3 times -3, so we draw this. Now, if you drew this right, it should form like a crescent moon shape. See that? That way you always remember this. Looks like a moon, okay? First, outer, inner, last. FOIL, first, outer, inner, last. So let me show you that math. First, x times x. So that's x times x. Outer, so you put plus. X times -3, that's -3 times x. Inner, -3 times x, so plus. See what I'm doing? X times x plus -3 times x plus -3 times x plus last, -3 times -3. So plus -3 times -3. So x times x is x squared. This is going to be just like this. Then you got -3x. Then you got -3x. Then you got plus 9. Combine like terms in the middle, these two. You've got x squared minus 6x plus 9. See how we got to the same answer? So I showed it two different ways here. Most students prefer this, but some teachers will demand that you do this. Okay, so please be aware of both methods. Binomial expansion. This is called a quadratic. Okay, quadratic, because it starts with the x squared. Okay. And we're on to the last problem, ladies and gentlemen. You've survived it. So this is number 8. And it says, what is, I'm going to just write it out. What is f of 8? That's how you read that. F parentheses 8, f of 8. And it really should say if f of x equals 3x minus 12. Okay, so this is called evaluating a function. E-V-A-L-U, evaluate, A-T-E, evaluate a function, okay? That's what we're doing here. What it really means in practice is just plug in the 8 everywhere you see an x. So let's move this down here. F of 8 equals 3, open parentheses, 8, close parentheses. That's, you've plugged in the 8 for the x, minus 12. So f of 8 equals, now 3 times 8 is 24, minus 12. So f of 8 equals 24 minus 12 is 12, 12. And there's your answer. Evaluating functions. Incidentally, anytime you evaluate a function at 0, you'll find its y-intercept. So like, look, f of 0, this is real easy. 3 times 0 minus 12 equals minus 12. So now you know the y-intercept. Pretty cool, huh? All right, that concludes the test review. And let me just go ahead and stop recording. Thank you guys for really paying attention. Appreciate it.